Hey guys, so I'm going to be talking about energy today. If you have any questions, remember you can come by and ask me. We're going to be having a quiz on energy on Friday. So first of all, energy is the ability to do work. We don't really have to cover work very much in seventh grade anymore, but basically work is a force exerted over a certain distance. And so energy is the ability to do that. And we've got two main types of energy, which is kinetic energy, the energy of movement, and potential energy, which is stored energy. Potential energy has to have the possibility of moving in the future. So it can't have potential energy if it's not going to move, or we have no idea if it's going to move later on. It has to have, like if you're drawing a picture, right, it has to be something that's like on the top of a hill, or like I talked about in class, a soccer ball with a foot, right about to kick it. That's got potential energy because it will move in the future. So you've got some notes that look like this. At the top, with the little car A, we've got a lot of potential energy there because it's up really high. We know it's about to go over the hill. And then B, it's going to go really fast at B. So it's gaining kinetic energy. It's actually gaining more and more kinetic energy as we go down the hill. And it's going to be losing potential energy because it's getting lower and lower, becoming lower and lower. And then at C, we have a lot of kinetic energy. That's the point where it's going to be going the fastest. And then at D, it's going to start going up the hill again. So it's going to be losing kinetic. It's going to go slow there, but it's going to be gaining potential. If I were to continue going and have a point at the top of the second hill, that would also have potential energy. It would not have as much potential energy as letter A, though, because the hill is shorter. It's a lot smaller, but it would still have potential energy. So here at A, I have a high potential energy. B is high kinetic. C, I'm going to have lots of kinetic at C. And then D, I also have potential energy here, but it's going to be a lot lower than A. Energy can never be created or destroyed. This is called the law of conservation of mass or matter, or the law of conservation of energy. In other words, energy is not going to just appear or disappear. It's always just transforming from one form to another. And so that's what we're going to go over in this PowerPoint, in this presentation. We're going to talk about the different types of energy and how they transform from one form to the other. So the amount of total energy is always the same. It's just going to change form. So here at the top, I want you in the little, I'm going to call it the pizza at the top, I want you to be writing down at least 3 examples. And then I want you to write down the definitions at the bottom. And I've changed them. They're not the same as what's on here because I kind of made my own that I like a little bit better. And in some cases, they're shorter. But at the top where it says the conservation of energy forms, I do want you to write down total energy before equals total energy after. So that's that law of conservation of matter that we're talking about again. To start off with, light energy and radiant energy are the same thing. We also call it electromagnetic energy, and it's all about moving electrons giving off light. So for your examples, you can put the sun or a light bulb or your phone because it lights up. Anything that has any kind of light is going to be radiant energy or electromagnetic energy. Nuclear energy comes from the splitting of a nucleus. So some examples of this are a nuclear power plant, a nuclear bomb, which is also called an atomic bomb, or the sun also has nuclear energy. Nuclear power plants are a little controversial because we do get clean energy, quote unquote clean energy, but they can be dangerous because they can release radiation if something goes wrong and that sort of thing. But it is a form of energy. It's nuclear energy. And what they do is they take a neutron and they shoot it at a nucleus of an atom and it splits and releases energy. Electrical energy is going to be anything electrical. Anything that you plug in has electrical energy, and it's basically the flow of electrons. So that should be pretty easy to remember. So your phone, when you plug it in, your computer, your PlayStation 4, or whatever you've got that can get plugged in, that's going to be electrical energy. Thermal energy is all about heat. and the motion of atoms. When something has a really high temperature, the atoms are moving really, really fast and they're bouncing against the thermometer and making the alcohol in the thermometer rise. When something is cold, the atoms, the molecules are going to be moving a lot slower, and they can get so slow when it gets super cold that they stop moving, which is basically when it freezes. And so that's thermal energy is basically a measurement of heat, and heat is the movement of atoms. So anything that gets hot is going to be thermal energy, like your blow dryer or a stove, a fire, a heater. All of those have thermal or heat energy. Mechanical energy is a synonym for kinetic energy. Anything that has motion is going to have mechanical energy. A clock, a bicycle, a car, those are all going to be moving, and so they are mechanical energy. The way that I remember what mechanical energy means is I think of a mechanic. That person deals with the moving parts of a car when they fix your car. So mechanical energy is all about movement. Sound is vibrations. So what I'm trying to show you here in the picture is when you hear me talking to you or you hear any type of sound, there are vibrations coming from me going through the matter between us, basically a gas, all the way to your ear. And that matter, those molecules are vibrating until they get to your ear. And sound can travel through solids, liquids, or gases. Whenever you feel something vibrate, that's sound. You can talk to your friend while you're swimming underwater, and that's vibrations also, so it's also sound. And then gas, it's gonna actually travel the slowest through gas, like when I'm talking to you, a little faster through liquids, and then the fastest through a solid. You cannot hear sound in space because there is no matter for it to travel through. There are no molecules for the vibrations to go through. So anything that makes sound would be like an MP3 player or a stereo, your phone, when you're watching a YouTube video, all of those are going to have sound energy. Chemical energy is when chemicals break bonds. For example, in a car, we burn gasoline and we're breaking the bonds in those molecules and they're releasing energy. Another example is photosynthesis. Any type of food is also an example. Plants are basically food, so that's going to be chemical energy. A pizza is chemical energy, and then also batteries are going to be chemical energy. If you ever have an old toy that you left the batteries in, you might have seen that the batteries exploded and there's like this white kind of powdery stuff everywhere. And that's the chemical that's inside that's actually giving the battery power. So I want you to write down 4 examples for this: gasoline, photosynthesis, food, and batteries. Heat. So we're going to just kind of concentrate on one of these types of energy. So heat is thermal energy that's moving. So it's transferring from one place to another. It's moving. And there's 3 ways that it can move, okay? So just a reminder, like I talked about with the thermometer, right? Thermal energy is about moving particles. It's all just the moving particles. The more they're moving, the hotter it is. If they're not moving very much, then it's cooler. So heat transfer happens when the energy is moving from one thing to another. And then there's a reminder here about the law of conservation of energy, which I just talked about. And the thermometer, which I also just talked about, is measuring how much the particles are moving, right? The more that they're moving, then the more that the hotter it is. If they're not moving, as they slow down, right, it's cooler. And once they stop moving, that's when it's frozen. So radiation is the first type of heat transfer, and this is when heat goes through space. For example, the sun. You've been outside and you feel the heat from the sun on your skin. That is radiation. It's just traveling through empty space. Or you pass by a fireplace or a campfire and you're not touching the fire, but you can still feel the heat. Or when you pass by a stove, you can still feel the heat, or a heater. So maybe some of you guys have a radiator at your house, which is a type of heater that just is really, really hot, and so it releases heat into the space and fills up the room with heat to keep it warm. So I want you to write down 3 examples for this also. You could write down a campfire, the sun, a heater. All of those are good examples of radiation. Convection is all about the mixing of things. Hot stuff like hot liquids, water, and hot gases are going to rise or float. This is why a hot air balloon works. That they heat the air that's inside the balloon and it floats up. Stuff that's cold is going to sink. So for example, like when you open up the refrigerator, the cold air comes out and it touches your toes first because cold stuff sinks. And so this movement, when something gets heated, like at the bottom of a pot, when it floats up, it's going to, it's less dense, right? When it got hot, and so it's going to float up, and then it's going to get cool and then sink back down. So that's called a convection current. And this is how heat moves or how heat mixes in things that are fluid, which is a gas or a liquid. Conduction is when things are touching and the heat is getting transferred. So for example, a pot touching the stove, or your egg touching the pan as you cook it, that's conduction. So anything that touches stuff that is transferring heat is going to be an example of conduction, like a curling iron or a hair straightener, a pan on the stove, an iron, you know, as you iron your clothes. All of those are examples of conduction. Here's an example of all three. Conduction, because the guy's hand is touching the hot handle. Convection is happening in the pot as it's mixing, and then radiation is coming off of the stove and heating the area around it, so it's traveling through space. I wanted to give you some examples of some transformations of energy, just as kind of a review, which is what we've been doing in class. So wind turbines would be mechanical energy because they're moving, right? The wind is blowing and moving the turbines, and that's creating electricity. So in the light bulb. So then you could say it goes to electrical. You could also say it's going to radiant because it's light. A battery to an MP3 player, the battery would be chemical energy, and then the MP3 player would be sound or light energy. The gasoline would be an example of chemical, and then in the car, you could say that that's mechanical energy because it's making the car move. Here we have a dam that's actually holding back water, and at the bottom of the dam you have turbines that turn as the water is slowly released. So you could say that the water behind the dam is potential energy, the turning of the turbines is mechanical energy, which creates the electrical energy that's sent to your house and powers your TV, which is going to be sound and radiant energy. Photosynthesis, the sun is radiant energy, and then the plant is going to be chemical energy, which is also an example of food. And finally, I don't want to make you hungry, but pizza is food, so that's going to be chemical energy. And then you're going to have the chewing and everything, which would be mechanical, and then it, you know, gives you energy to run, so that's going to be mechanical, or you could also say kinetic because that is a synonym for mechanical, right? Okay, so this is the end of the presentation. Study for the quiz on Friday, and I will see you guys in class. So let me know if you have any questions. Thanks for watching.